Last class, who was here last class? Were you guys all here last class? Excellent. So just as we were finishing last class, we were talking about ratios. Like people have 2 arms for every head, correct? That's a ratio. Apples have 12 seeds for every apple. Now, I don't know if that's true or not. It might not be that. But you know that there's some number, right? What are some other ratios that we can think of?
2 eyes for each face.
2 eyes for each face. Any other ratios that don't have anything to do with humans?
10 chocolate chips for each cookie.
All right, 10 chocolate chips for every cookie. Now, it might not always be that, right? But might be. How about chairs?
4 legs for each chair.
4 legs for each chair. Okay?
8 chairs for each table.
8 chairs for most tables.
Or 6.
So
Or
4 legs for every 1 chair. Correct? I can also write that as for every 1 chair, there's 4 legs. Whoops, L-E-G-S. Does that make sense? So I've written it 2 ways. Can you see that? You can write it more than 1 way. All right, and that's important because what these are tools to help us relate the amount of one thing to the amount of another. Okay? Does that make sense? And they're ratios. So like when I say 1/2, right? 1/2, I mean a half of something, correct? A half of something. So it's like if I'm thinking of a pie, here's a pie or a pizza, right? And I have half the pizza that I'm going to eat here, right? Does that make sense? So there's 1 piece out of 2 that make up the whole, right? 1 part out of 2 that make up the whole, okay? And we have to know how to multiply these ratios or these fractions, right? If I multiply 1/2 times 2, because I can also write this another way, right? I can just write, instead of 1/2, I can write 2/1. They can come in. So, what happens if I multiply 1/2 times 2? Do you know? If I have 2 1/2s.
Find a seat.
If I put it, multiply. Does that make sense that I would have a whole pizza if I have 2 halves? So what you do is, I don't know if you guys are familiar with multiplication problems, but you multiply this number times that number, right? And then you divide it by that number. Does that make sense? Okay, so the answer to this is what? What is the answer to this? It's 1. That's right. So 2 times 1 is 2, divided by 2 is 1. Does that make sense? So we need to be able to know how to do those types of problems. Let's do one more here. 1/4 times 2. 1/4 times 2, what's the answer? Well, this means I have 1/4 of a pizza, right? And if I multiply it by 2, how much of the pizza would I have?
1/2.
If I had 2 of these quarters, right? And I put them together, because that's what the multiply by 2 means, and I put them together, then I would have 1 of the quarters here and 1 of the quarters here, which would be how much of the pizza? Half of the pizza, right? So 1/4 times 2 equals 1/2. Can you see that? And what we did is we multiplied the top numbers, 2 times 1, correct? And then what did we do? We divided it by 4. All right? Now sometimes that requires, because the numbers get big, and we don't have time to sit around and do it on paper, sometimes it requires a calculator. Okay? I'd like you guys to bring a calculator to class next time you come. Do you think you could find a calculator at home? I'll bet you your parents have some. Just ask around and I'll bet you you'll be able to find one. But everybody needs to be able to bring a calculator so that they can all begin to do the math without having to write it down, because we don't have time to do all the math. Like this crazy number here, 276 times 4. Do you guys know what 276 times 4 is? Me neither, right? So what you have to do is 4 times 6, 24, carry the 2, 7 times 2, 4, 28, 9, 30, right? So that's going to take way too long, especially when we have multiple numbers that we're going to have multiple calculations that we're going to have to perform. Okay? So can you guys bring a calculator on Monday?
Yes.
All right. That's going to be necessary. Now look at this one here. 1/4 times a 2 equals 1/2. All right. Now these are just numbers. It's like art. It doesn't really mean anything specifically. We haven't said it's a quarter of a pizza or it's a quarter of a car. We haven't said anything like that. It's just the numbers, and it's beautiful, right? It's wonderful to think, ooh, that's a true statement. Hooray, right? But we can give these statements units. So like, for every, well, let's try this first. For every 1 chair, I know that there are how many legs on the chair?
4.
4 legs on the chair. And then if I have 2 legs,
You have half a chair.
how many chairs can I make?
Half a chair.
Does that make sense?
Make a chair.
Now we've taken this beautiful statement and we've made it applicable. We've applied it to something. We can answer a question. If I know that 1 chair takes 4 legs and I have 2 legs, I should be able to make a half a chair. And so I take this number, 1, multiply it by that, 2, and then divide by that, 4, and then that should give me again 1/2 of a chair. And that's how many chairs.
Does everyone see that? It'd be 2 divided by 4.
Times 1 divided by 4. Now when you have your calculator, if that math is too hard for you because you're too young and you don't know what times means and stuff like that, your calculator will help you get the right answer. Okay? Does that make sense? Your calculator will actually not say 1/2. What would it say? 0.5, right?
Uh-huh.
Okay.
He's in kindergarten.
0.5,
It's okay.
right? 0.5 chairs. Now, what happens to the units? The units that we added, chairs and legs and legs and chairs, what happens to the units? How do they get divided or multiplied together? They do. They do. Did you have any ideas? No, did you have an idea? What was it?
Idea was that one tail it finds one leg finds another leg, so it comes to another leg.
Okay.
And
What I'm wondering is, how do I multiply chairs times legs?
use the numbers.
I know I multiply 1 times 2. That makes sense. But how about chairs times legs? Is it a problem to multiply chairs
I
times
have
legs?
an idea.
Yeah.
Can I tell what my idea was? Yeah, what about to make the half of the sail not part of the other sail, so the sail could have 6 legs.
So it'd be nice if we had 4 legs here or 6 legs here to make more than a chair, more than a half a chair.
I mean, there would be that one sail would have 6 legs.
Ah, yeah. Well, that would be a different kind of thing, right? What we can do with our units is just like any other multiplication or division thing. If I multiply chairs times legs, then it's chairs legs. But then when I divide by legs, the legs cancel out.
It's like it's 1 and 1, right?
What is 5 divided by 5? It's 1. If I write some units on here like grapes, G-R-A-P-E-S, 5 grapes divided by 5 grapes, it's still 1, right? The grapes cancel out. Does that make sense? Nope, the grapes cancel out. So it's just one thing without any units at all. Okay? So that's nice because then we can see that our answer should have the units of chairs because legs cancel out there. Does that make sense? So let's try it again. It's a little bit complicated, and there's 2 ways that you're going to learn it. 1, you're going to learn it by just, oh, I get it now. And 2, you're going to learn it by doing it over and over and over until it becomes commonplace to you. And you don't ever get it. You just do it the right way. Does that make sense? How many leaves are on a tree?
Lots.
That's not a number.
1,000.
1,000? Let's use 1,000. Let's use 20,000.
Yeah.
All right? 20,000 leaves for every one tree.
No, for every 2 trees.
If I have 3 trees, right, I should be able to multiply this by what?
3.
3, and not just 3, but 3 trees. And I should be able to know 3 times 20,000
60,000.
divided by 1, right? Still 60,000. And what should my units be? Leaves. 60,000 leaves. Now, is that what I would expect the answer to be?
Yes.
Yes. Correct? Okay. Let's try again. Now, I'm going to give you the question, and you're going to tell me how to set it up. Okay? If I have 100,000 leaves on the ground, how many trees must there have been? If I have 100,000 leaves on it, I don't want the answer. What I want is how to set it up.
So you do the 2 leaves and 1 tree.
So here, to the right of the equal sign, that's where we start. We write what we're after. What is it we're trying to figure out here?
100,000 trees. How many trees?
No, I told you you had 100,000 leaves. You already know that.
Trees.
We want to know how many trees there were, right? So I'm going to put a question mark and write trees. Does that make sense?
Yeah. So 100,000 leaves divided by.
And then I make a little line here. It's kind of like a workspace so I can see what to do. Okay?
1,000, 20,000.
And I know that I need to get to how many what? I need to get to how many trees, but I need to start with, I told you how many what did I have? 100,000 leaves. So I write what I start with over here. Here's 100,000 leaves.
Leaves 100,000.
All right, 100,000 leaves. And now what am I going to multiply that by?
Nothing. You're going to divide.
1.
You're gonna divide
I need
by
to get
20,000.
trees in the end.
You're going to divide it by 20,000.
So
Oh, you're gonna
trees
divide it by
needs to
2
be up here.
20,000.
Trees needs to be up here. So I need to have my 1 tree up here. And down here, 1 tree, each tree has how many leaves did I say?
20,000.
20,000. 20,000 leaves. Does that make sense? So now I can see the units do what? Leaves divided by leaves. They're gone. I'm left with trees like I wanted. So now I just take the 100,000 divided by 20,000 in my calculator,
5.
and I should be able to get an answer.
5.
Question? 5 trees?
It's 5 trees.
How much time, Mom?
2 more minutes.
Okay,
So much simpler.
so let's try another one. Okay? If I want 3 moles, no, let's see. I'm going to write the question up here. If I want 2.7 moles of sodium, how many grams of sodium do I need? If I want 2.7 moles of sodium, how many grams of sodium do I need? Okay? Now, rarely is solving this about knowing the number. What you need to solve it is know how to set it up. Because after you set it up, then your brain doesn't have to think. The more you make your brain think, the more likely you're going to make a mistake. So if you can think about how to set it up and think about how to think about it, then you don't have to actually think about it.
What?
Make sense?
What?
So you make it simple for yourself by knowing how to set it up as opposed to just knowing, oh, I multiply this number by that number. That make sense?
Yes.
So I'm going to write an equal sign, and to the right of the equal sign, I'm going to write what I'm looking for. What is it I'm looking for in this problem?
How many grams?
I'm looking for how many grams of what?
Sodium.
So I write down grams of sodium. And then I draw my line, and here I write what I'm starting with. What am I starting with here?
2.7 moles.
2.7 moles of sodium. All right.
We don't know how many.
What units have to be down here?
The gram. How many?
What units? Do I want moles in the end? I don't want moles of sodium. I want grams of sodium. So I have to get moles of sodium down here, right, to get rid of them. So I'm going to write moles of sodium down here. Do I know how many grams are in 1 mole of sodium?
No, but it's on the periodic.
But I can look on the periodic table. Can you find Na on the periodic table? Keep looking. I think it might be number 12 or something, or 11.
It's on. It's in the randomized series. It's not 22,000.
Did you already look at the periodic tables once?
We found it.
Ever?
You found it, huh? 20, rounded up to the whole number. 20,
About 23.
23. And what are the units on that? 23 what?
50 grams.
That number is how many grams you need to weigh out to get 1 mole. Does that make sense? So to get this answer, what would I have to do on my calculator?
Yeah. Times 2.7.
2.7 times 23 grams.
Divided by 1, right?
1.
Does that make sense?
Yes.
All right, so then moles of sodium would cancel with these moles of sodium, and I'd be left with grams of sodium.
Okay, 23 times.
But it wouldn't be 239. It would be something like
This is grams. This is grams. 23 grams.
yeah.
That's a G. So 22 point something, and it rounds up to 23. So that's fine for us.
But
So the answer isn't 23. It's 23 times 2.7, and that's what we're going to be able to do when we come back with our calculators on Monday. All right? We need to learn how to do this. You guys are brave. You guys are brave. This is something that might be foreign, weird, uncomfortable, but you keep coming, which is important. You notice that some people have stopped coming, right? You guys are going to stick with it. And as you stick with hard things, then you begin to grow in ways that you can't even imagine. So I encourage you to keep coming and keep sticking with it, because I'm going to give you an A. Ha ha ha. You don't get a grade for this class, right? And you wouldn't even care if you did. And that's good, because you shouldn't care about the grades. What's important to care about is that you're learning, growing, not being afraid of hard things. And that's what I'm hoping you gain. You might be, though. You might not recognize it, but you might be. But because you're showing up, you're showing that you're brave, and you're going to keep trying. All right, I'll see you guys on Monday, okay?
Is it going to be the same time or?
Same place, same time.